Hey guys, it's Miss Gephardt, and we're going to go through and go through the chemical reaction notes. So just make sure you are listening in and taking very good notes. All right, so we've already gone through what a physical and a chemical change is. So we know physical changes are things that are not permanent. A chemical change would be something permanent, and a new substance would be produced. So a chemical reaction is something it's a chemical change. It's going to show that we've got let's do this. We've a new substance being produced by changing the arrangement, and so that's going to tell us a chemical change has occurred. The bonds between atoms are going to be broken and new ones are going to be formed, and that's why it's a chemical change, because we've actually taken the atoms and we've broken up the bonds, rearranged them all, and put them in a different way. So that's a chemical reaction. A reactant is the stuff that we start off with. So that's, if I start off with stuff right here, stuff present at the beginning. So let's say I have like salt and baking soda. And I have those two sitting in my hand, each of my hands. I'm holding one of the containers of each of those. Those are both reactants, so they're going to start at the beginning of a reaction. And then I mix these two together, and let's say it forms something. Or let's do baking soda and vinegar. That's a better one. So I have baking soda and vinegar, and then I pour all the baking soda into the vinegar. I'm going to get this bubbling action, this lots of bubbles and like kind of fizzing that's going on. That is going to be the product. It's what is produced from the two reactants coming together. All right, so if I were to look at a chemical equation, which is what you see here, the reactants are going to be the stuff that is present at the beginning, like we just talked about. And so that's this stuff over here. So this is methane right here, and then I've got oxygen. If I put methane and oxygen together, I'm going to get carbon dioxide and some water. Those are the products. So we have reactants, what we start with, products is what we finish with. All right, 4 ways to detect a chemical reaction. So there are 4 ways that you know a chemical reaction has occurred. The first way is color change. Now, I want you to think though, if I add food coloring to water, that is not a chemical change. It is a physical change. It is still water. It is just whatever color I made it. If it was blue or if it was green or whatever, it's blue water. It's green water, but it's still water. A color change in a chemical reaction means I have mixed 2 things together, and like 2 different substances, and I have all of a sudden a change occurring. So, for example, and it's something new. Okay, so if I look at a nail and I put it out in the elements, okay, that iron nail is going to turn brown. Okay, this is the color change part. Okay, I could have 2 very clear substances and they mix together and it turns hot pink. That's what we mean when we say color change. The second is something called the formation of a precipitate, and a precipitate is this word right here is a solid. Okay, so that's kind of what it means. So that means I'm putting 2 liquids together and I get a solid. And you can see the solid right about there. That's the solid. It kind of chunks up. We'll do a lab that you'll be able to see a precipitate in it. But the formation of precipitate means 2 liquids come together, they react, and I get a solid. A third type is the formation of a gas. Okay, now formation of a gas doesn't mean I am going from it's not water boiling and then evaporates. I know that's a gas, but I'm taking this liquid and this solid and I'm mixing it together and I get that bubbling. So it would be like baking soda and vinegar and mixing those together and you get this bubbling action. That is the formation of a gas. Finally, we have a temperature change, and temperature can be seen with it could just be that the beaker gets gradually warmer, so we could see it as warm, or we could see it go up as a flame. So that's, again, I'm taking 2 substances, mixing them together, and I get a temperature change. Okay. Exothermic reactions are reactions in which energy is being released. So when you think of an exothermic, and these are very specific types. So exothermic, it means that the energy is exiting, it's being released off. So you're going to feel that. That's going to be in like heat form. It could be the pop up into flame, but also heat. The other type of reaction is endothermic. So I want you to think of inside this endo part right here, and that means that the energy is being absorbed than released. So more is being absorbed rather than being released. So we're absorbing it in, which means you're going to probably detect it getting cooler. All right, 3 factors that will affect the reaction rate. So how quickly the reaction goes. If I'm mixing vinegar and baking soda together, things that could affect how quickly that reaction happens. The first is the concentration. How concentrated is the vinegar? How much baking soda did I put in there? Second is the surface area that I'm working with. Do I have a very small beaker that I'm working with, or am I a very big beaker? The third is the temperature that it's at. Am I at room temperature? Am I heating this up? Am I doing this in a freezer? These would all be things that affect how quickly that reaction is occurring. Finally, there's something called a catalyst, and a catalyst will increase the reaction but will not be consumed in it. So what that means is it's kind of part in the reactant part, but we're not going to really see it in the product part. An example of a catalyst for you guys is going to be your spit and saliva. Okay, so when you start chewing your food, you already know that your food starts getting liquidy, starts to break down. That's because there are enzymes in your saliva, which are catalysts, that help speed up the breakdown of the food so that you can chew, and then you swallow it. And then it goes into your tummy, and your tummy does the same thing. There are enzymes being released that are speeding up the reaction. They're just speeding up digestion. They're not going to be found in the product. And with that said, that is all the notes for chemical reactions. If you have any questions, please make sure you see your teacher and come ready to discuss this further in class.